Hello, in this video I'm going to show you how to find relevant papers and visualize them in an interactive graph. So the website we're going to use is called connectedpapers.com. So you can Google it or you can find the link in the description. So this is a website that I just found recently and I found it's very useful. It's free. You can sign up for an account. You don't have to pay anything. So if you are working on research or you need to write a report or you need to write an article, and if you need to find papers, you need to cite and to find out which papers are connected, which papers are relevant, then this website might help you. So again, navigate to connectedpapers.com, and then from here you can just search any keywords, or you can directly click some of the examples down below here. And so for me, I would just you can search a keyword, you can paste a DOI or paper title, whatever you like. So I'm just going to type, for example, Google Search Engine. That's something I'm interested in. So and then just search the keywords, and then from here you should be able to find some of the papers relevant to this. And for example, let me click the first one. So this is a very well cited paper written by the Google Search Engine team. So as you can see, it's pretty interactive and responsive. So now on the left side here shows you the list of papers related to the keywords that I just searched. On the right here, on the right panel here, when I'm moving my mouse, you will see that on the right, the paper also being updated. The most interesting part here is the one in the middle. So you can see we have a lot of these kind of bubbles or circles, and the size represent the number of citations. So you can see the links between those papers. You can zoom in, you can zoom out. It's kind of interactive, so take a look. Right. So on the right here, you also see the paper that is updated when I'm move my mouse or hover my mouse over the bubble, right? And so the color represent the year. So in this case, for Google Search Engine, so the earliest one is from 2012 all the way right now to 2020. So the darker the color represent the more recent papers, right? And the size represent the number of citations. So you can see, for example, right now, this Google Search Engine paper by Golick 2017. On the right here, you also see the number of citations. So 911 citations. You also have the another one, Hansen 2013. So this is probably the almost the first paper that utilized Google Search Engine to do global forest mapping, and this one was published in Science. So over 6,800 citations. So on the right here, I also show you some information. So this gives you a quick overview of, for example, which paper is connected to which paper, right? So if they're connected, you will see they're a bit closer, right? It's just like a cluster, and you also see the name and the author, right? And if you see, for example, I also have a paper 2010, right? So this is about GMAP. You can also see on the right here. It's somehow also connected to this paper. So take a look, right? And zoom in and zoom out. So for example, if you're clearly on this paper, you will see that, okay, these are the two very big bubbles. So the Hansen 2013 and also the Pecco 2016. So this one was 2017. So it was kind of based on, kind of related to those two early articles. So if I click the 2013, on the right here, also shows you the information. So for this one here, you can also build a graph, right? If you click this one here, open in Connected Papers, right? It's going to open a new tab. So now you see this Hansen 2013 paper. You're going to have a new graph in here, and also somehow also connected, right? So this gives you a quick way that if you want to find, for example, for this specific article, what are some of the most important papers that have a similarity to this one. So now you have, for example, roughly, I'm not sure how many, maybe 20 articles, something like that. On the right here, you can also go to Semantic Scholar. So there's another website that allows you to basically search articles and also find the relevance, but it's kind of a list, so you don't know really which one are very relevant. Of course, you can also use Google Scholar, but it's just it's kind of random, so it's not necessarily all connected. You can also look at the citation numbers, but you don't really know are they all kind of relevant, because citation that sometimes a paper has a citation does not mean that it's relevant to the paper that you are interested in. So, but this one clearly is very impressive that you can see the circle, you can see the size, so you can quickly get an overview of what the papers. And also, for example, you go to the publisher page, right? You can click the DOI. It's going to navigate to the page in here, and then you can read more if you want, or you can download the paper. You can also go to Google Scholar. Again, right, this paper here, go to Google Scholar, and then you will see cited by this one. So if you click, you get like 6,000 articles. It's just way too much. And of course, you can go to them. By now it's ranked by citations, but it's not always relevant, right? So you not really ranked by citations. This one is 2,000. This one is 1,900. So, but I think this one gives you a better overview. And lastly, what else? So another interesting point is that let me go back to the Google's engine paper here. For example, you can click the button here, prior works, right? And it's going to show you, I think, roughly 10 articles that are most relevant that this Google's engine paper is related to, or has a high similarity. So these are pretty much some very important papers. For example, the Hansen 2013, and also the surface water changes published. That this one is in Nature, right, 2016. So those are also very high citation papers, but not necessarily all like very high citation, but they are very relevant, for example. And so once you click this one, there's a button here allow you to download the to computer. So you click the download button, it's going to save this one to your computer. So for example, and then click save, right? So from here, open, and so it's a .bib file. It's just a basically a TXT file. You can double click and open this one. So you can easily import this one into reference managers, for example, and or whatever software that you're using. Most of those support this kind of a format, right? So you get all the articles all at once into your reference manager without having to download them one by one. So it's pretty straightforward. You can also download the other one. So derivative, so the prior works means the paper that are based on or cited by this paper. Derivative means other papers that have been published but is highly relevant to this paper. So again, you can also click the download button and download this one, and then click open, right? So you can also see this one. So again, very easy to use, and yeah, right now that's pretty much that. You can also save this one to your computer. So for example, let me click here. If you're very interested in this one, on the right here, for example, let me click here and then click the save button. So you need to log in. So if you click save, or you need to log in first. So you need to log in, for example, using your Gmail, or you can sign up for an account. And then once you log in, you should be able to click the save button. Right, click save. It's saved to your account. So for example, I can click maybe the other one, and then click save. So from your account, you will be able to see save papers. Take a look. Right, so now you see here, and again, if you want to take a look at that, on the right here, click this connected papers again, open, and then it's here again, right? So this could be very useful. You can also click, if you zoom in and zoom out, for example, just click the center button. It's going to return to the original view, and the hair button, right? So the note size represent the number of citations, the color represent the year, and so if a paper they are similar, they are connected together. So pretty simple, and I hope you find it useful. You can try it out using your own paper or any resource topic that you are interested in, and see how the papers are connected together visually using this kind of graph. And you can also download the references to your computer and then import into reference manager. Okay, so that's all for this video. I'll see you in the next one. Take care. Bye bye.